Hello and welcome to this lesson video where we will learn about excavators, their use on the construction sites, and the way to calculate their excavation rate. The video covers the shown 4 learning objectives. There are five main types of excavation equipment. First, shovel is heavy equipment that excavates above the ground. Hoe are designed to dig below the grade. Loaders are mainly used to load the excavation spoil into the trucks, but it can still help in the shallow excavation operations. Finally, drag line and clamshell are cranes that transform with clams and drag buckets for special excavation operations, like waterway and marine construction. For this lesson, we'll focus on front shovel and hose. As we hinted in the previous slide, front shovels are designed to dig the soil formation above track ground level. You can see it from its upward arc of the bucket reach. Front shovels are used in heavy construction projects with large soil formations, like roads, levees, and dams. To stay balanced in such excavation operation, the front shovels are heavy and large. On the other hand, hoes are primarily designed for below track level excavation, but they can also handle above grade excavation. They have equilibrium advantage in this case, and this is why hoes are generally smaller and lighter than front shovels. Hoes are also handy in performing other tasks beside excavation, as we'll see in a later slide. This photo here is just a visual of how large front shovels can be. Excavators can be track mounted or wheel mounted. Generally, equipment on tracks are more stable, but they are not that mobile within the site like the wheeled equipment. However, wheeled equipment need additional stability precautions, especially when dealing with heavy loads or long reaches, like the outriggers used by this excavator, by this wheel hoe to reach far down this excavation site. Hoes are really like a Swiss knife on a construction site. Most of the buckets come with a hook, hole to attach and lift the load. This photo shows a hoe lifting a concrete pipe segment to drop into a trench. Also, the buckets can be replaced with drill mounts to use the hoe now for drilling wells or anchors. Finally, excavators can be really loud when equipped with impact hammer mount to demolish concrete structures. After comparing between front shovels and hoes, let's focus on hoes and their production estimation. Let's compare between the traditional hoes and the back hoes. Traditional hoes are heavier and usually on tracks. Back hoes were designed to provide more mobility and versatility on expense of the ability to deliver large production rates. Hoes are equipped with only a bucket or another type of attachment. Back hoes have a loader style bucket and a hoe arm with a small bucket on the back. The combination between the loader and hoe buckets make the back hoes versatile for different work requirements. Hoes are mostly for large operations, while back hoes are for small projects like small utility trenches. But hoes don't require much maneuvering space around them, as they can rotate 360 degrees around the track axis. Back hoes need maneuvering space around them, as their back hoe bucket rotation is very limited. Now let's see how we can model the production of the hoe excavation. We will model a single cycle of the hoe operation, which includes three main movements: bucket loading, swinging with the loaded bucket, and dumping the bucket load, and then swinging back with the empty bucket. So actually there are four movements. Recognizing these four main steps within each cycle will help in estimating the production of the whole operation using the shown formula. Using the Hoe Excavation Production formula will require five main steps, which basically identify the values of the four main formula values: bucket size, fill factor, cycle time, and efficiency. The formula follows the typical production estimation principle of relating the cycle work amount, the effective bucket length, to the cycle time duration. The first step is to identify the bucket size, which is typically provided in loose cubic values as the soil swells during the excavation process. You will need to know what bucket size is installed in the hoe, and buckets can be changed. The buckets can range between 1.1 to 3 loose cubic yards, and this capacity can be increased to account for the heaped volume of the soil in the bucket. The next step is to adjust the heaped capacity by a fill factor to account for the impact of the soil type on completely or partially filling the bucket. The highest fill factor is for moist, loam, sandy clay due to its loose nature to fill the bucket and in the same time have more heap than other soils. The lowest fill factor is for the hard clay that fills around 85% of the bucket heaped volume. The third step is to estimate the excavator total cycle time, which includes four main repetitive steps we discussed before. The shown table shows the typical times of each cycle step and the whole cycle time for different bucket sizes. The excavator will need longer cycle times to fill, swing, and dump bigger bucket sizes. These cycle time values are valid for specific operation conditions in terms of the digging depth and swinging angle. So to use the manufacturer suggested cycle times, you will need to verify that you are complying with the suggested work conditions. First, your swing angle between the dig spot and the dump spot should be between 30 and 60 degrees. If you are outside of this range, the swing time should be adjusted accordingly. The depth and loading height should also be within an acceptable range relative to the maximum values provided by the excavator manufacturer. This table provides some guide values for the maximum digging depth and loading height. To use the suggested cycle times, you need to be between 30 to 60% of the maximum reach values for digging and loading. The fourth step in estimating the excavator production is to assume an efficiency level for the operation. Usually, the production rates available from the equipment manufacturer are ideal rates under specific conditions and are not dependent on other equipment or machines. You need to assign an efficiency factor to reflect the factors that prohibit the achieving this ideal production rate. The efficiency factor can account for the need for the operator to take bio or rest breaks, possibility of equipment breakdown or maintenance, and the bunching phenomena that happens due to the irregular speeds and travel times of the hauling trucks. We will cover bunching and more in more detail in another lesson on hauling operation. but you can know for now that bunching results in having no hauling trucks available for the excavator to load. So even if the operator or the equipment are ready to continue excavation, the loading part of the cycle cannot be done as there is no truck to load. Considering all these factors, your efficiency factor can be represented in a percentile value like 85%, or in the format of how many productive minutes per hour, like 50 minutes per hour. Finally, the last step is to just plug in all the values for you identified in the previous steps in the formula to calculate the excavation productivity of a hoe. Let's conclude this lesson with some safety precautions when dealing with excavators and digging operations. The list here shows the top common accidents that occur around excavators and trenching activities. This list is based on the safety data that are collected by OSHA, or the Occupational Safety Health Administration, and NIOSH, National Institute of Occupational Safety and Health. Being struck by a moving equipment or detached parts is the main safety hazard around. So it's the main safety hazard around excavators. This is why a typical heavy equipment has some loud beeping noise when the moving or to alert the worker around. Also, hard hats, safety distance around the equipment, and eye contact with the equipment operator are typical precautions to avoid being struck by the equipment. Also, falling in digging holes and the cave-ins or collapse of the trench walls on workers are also top safety hazards. This is why there are many regulatory requirements focusing mainly on securing trenches. Based on the soil type, the contractor will have to decide on how trench cave-ins will be avoided. This is done by allowing the soil to take its natural slope, forming slope in benches, or using trench boxes in tight sites with vertical trench walls. OSHA also calls for specific egress requirements for the workers inside the trench in terms of the existence of ladders and their spacings. Thanks for watching this lecture video, and I hope it was beneficial to you to learn about excavation operations, equipment, and safety precautions. See you in another video.